Okay, this is going to be the first of a series of 4 videos for this mass property analysis assignment. The first part we're going to make is this one. The strategy is, I guess we could think about this in terms of like a real machining process. So let's go ahead. We're going to make a rectangular prism that measures 5.125, 5 1/8 by 2 3/4 by 1 3/4, and then we're going to mill out all of the parts so we get this nice channel down the middle and these chamfers on the end. Piece of cake. Ready? So let's start a sketch on the front view, on the front plane, and look at it straight on. We're going to start by making a rectangle and dimensioning that rectangle. So what did we say? We said 5.125, enter, and then the height was 1.7575, enter. And so this is going to be the overall block size. We're going to extrude this block. How far are we going to extrude it? Go back here, 2 3/4. So we can come here and just type in 2.75, enter, and we've got the rectangular prism. Now, one thing I like to do is turn off these planes so they're not bugging me. So you just come click these 3 eyeballs, they all disappear, and you can even make the origin disappear too, so you have this nice fresh look. Okay, so first thing we want to do is maybe put the channel down the middle. The channel measures 5/8 by 3/4, and it is.
Samantha, you're unmuted.
It is centered, right?
Oh, sorry.
So let's go back here. We're gonna put a sketch right on the part, and take a look. We're gonna make another rectangle, and you notice a couple things here. We can make a center point rectangle, which is good for this application because we can truck down this top edge, and right when you get to the middle, it blows up a little marker for you. So you click and drag open that rectangle. Good. So we click again, and now we can add the dimensions. If we look at this again, we want 625 for the width, and then we want 0.75 as the height, and we're going to have to multiply that height by 2 because the center of the rectangle is right on that edge. So here we go. Oh, I lost it. Let's go back and dimension by clicking dimension. And so this was 0.625, and the other one is going to be 0.75 times 2. And so just to make you aware that you can always make your dimensions as formula, which is super cool if you think about it. Then we're going to hit extrude. So I finished the sketch. I'm going to hit extrude, and instead of having new, I'm going to say remove. And instead of blind, I'm going to say through all. So that just means if you made this longer, this is still going to cut through everything. Great. Boom. So this is almost done. We've got one more thing to add. We want chamfers. These chamfers are 45 degrees. And what do we know? We know that they're an inch down from the top, or 0.75 inches up from the bottom. So the overall height is 1.75 from the bottom to the bottom of the part to the bottom of the chamfer is 0.75. So those are all your clues. So let's go ahead and select chamfer, and we want equal distance. That'll give you the 45. And then I think for here you need to put 1 as your number. And then if we click that edge, zoink. How about this edge? Zoink. And now we've got some sweet chamfers, and this part is done. Feeling strong. So that doesn't look like that. So I guess we have to put 2 more chamfers on this side and this side because all chamfers are 45 degrees. This one doesn't look like it's the same depth as that one. So how do we get the right depth for this one? Well, it says here it's 1 inch from the bottom to the bottom of that chamfer. So we can say we've got a chamfer that's 0.75. So it's equidistant because that gives us the 45.75. Now if we click this, what happens? Ooh la la, game over. So now we've got the part is done. But you need to change the material, and if we look at this over here, it says the material is mild steel. So let's go ahead and change the material. So here's how you do that. You come over to part 1 and you right click, and it opens up this menu. You say assign material, and then you come through the library and try to find mild steel. Maybe it's down in the M's. What do you think? Molybdenum. Nope. Maybe it's up in the steel. Stainless steel, Sitka spruce, steel. I think there might be a special note in the instructions for distance learning, so let's go back here and see if we can't find that. Yeah, here we go, distance learning. So this should be ASTM A194 grade 2H. So that's what we're looking for. Stainless steel 194 2H. There we go. Shoosh. So that's correct. We hit the check mark. And now it has the properties of that steel. So let's see what that means. If we click down on these little scales, it displays our mass properties, and I think you just click on here and it's asking me what part to measure. So this is the part. If I come over here and click on this, it gives us all of the details. The only thing that's going to change if you change the materials is the mass. The volume stays the same and the surface area stays the same. So just keep this in mind. We got the mass is 5.128. Let's go ahead and change it to something that is way different. So let's just see if we can make sure that we're come on. Oh, clicking on the wrong down caret. Titanium, I don't know. Wrought iron, zinc, zirconia. How about rosewood or redwood, or what's Purple Heart? Let's change it to Purple Heart. So it used to be 5128. With Purple Heart, it is only 0.607. So you know that by changing, that's just a way to check. So first part in the books, and we'll start making the other parts.